Section 3.5 Rational Functions, question number 7, says to give the equations of any vertical, horizontal, or oblique asymptotes for the graph of the rational function. This graph does have a vertical asymptote, and you find the vertical asymptote by setting the denominator equal to 0. So we set x plus 3 equal to 0, and we get x equals negative 3 as the equation of the vertical asymptote. Okay. To determine if it has a horizontal asymptote, you need to look at the degree of the numerator and the degree of the denominator. The degree of the numerator degree, is equal to 2. Simply, it's the greatest exponent in the numerator is 2. The denominator degree is 1. The greatest exponent, you don't see it, is automatically 1. So we say the degree of the numerator is bigger than the degree of the denominator. So this has no horizontal asymptote. We call that kind of like a top-heavy function. The degree of the numerator is bigger than the degree of the denominator, so it has no horizontal asymptote. And you can refer back to the notes when I talk about, let me go back a few pages and show you. Top-heavy, the rational function, the degree of the numerator is greater than the degree of the denominator, so there's no horizontal asymptote. However, there is going to be an oblique asymptote. Let's check that there's no horizontal asymptote. And then to find the equation of the oblique asymptote, if the degree of the numerator is 1 more than the degree of the denominator, then there is an oblique asymptote. The equation is going to be in the form of y equals mx plus b, where the mx plus b is a result of synthetic division without the remainder. So let's go back to number 7 here. To find the oblique asymptote, you want to use synthetic division. You're going to take x squared minus 7 and divide it by x plus 3. Remember, in synthetic division, if you're dividing by an x plus 3, then you're going to put a negative 3 in the box. What you're dividing into is x squared minus 7. Now, x squared minus 7, that's the same thing as x squared plus 0x minus 7. So the setup is going to be 1, 0, negative 7. Bring down that first term, 1. You get 1 times negative 3 is negative 3. 0 and negative 3 is negative 3. Negative 3 times negative 3 is a positive 9. And in this case, the remainder is 2. The equation of the oblique asymptote is going to be in the form of y equals mx plus b. And that is what we're going to get. We're going to get the m, the slope is 1, the b is negative 3. So y equals x minus 3 is the equation of the oblique asymptote. Now you can check that this has a vertical and an oblique asymptote by looking at the graph with a calculator. When you go to the y equals, you want to put the entire numerator in parentheses. So I'm going to write this as x squared minus 7 in parentheses, divided by, in parentheses, the entire denominator, x plus 3. I'm going to do a standard zoom, and hopefully that's going to be big enough so that we can see that it has a vertical asymptote at negative 3, that vertical little jump in the graph. And you see how this graph does not flatten out? It actually looks like it approaches this oblique asymptote, and the equation of that oblique asymptote is y equals x minus 3. So the way you determine any asymptotes without a calculator is by setting the denominator equal to 0 to find a vertical. Look at the degrees to find a horizontal. And then if the degree in the numerator is 1 more than the degree of the denominator, then you're going to use synthetic division. Let's look at number 8. Give the equations of any vertical, horizontal, or oblique asymptotes. Well, the way you determine the vertical asymptotes is by setting the denominator equal to 0. So we're going to set 2x squared minus x minus 21 equal to 0. And this, perhaps we can factor, use a quadratic formula to determine where the x's, what values of x would make the whole denominator equal to 0. All right, so you can solve this quadratic equation by factoring or by using the quadratic formula. This one can be factored. You can go through, use the AC method if you need to find those factors. One factor is 2x minus 7 and the other factor is x plus 3. You can double check that. 2x times x is 2x squared. The outer is 6x. The inner is negative 7x. That gives you that negative x and then minus 21. You're going to set each of those equal to 0. And you get x equals 7 over 2 is one of your vertical asymptotes. And x equals negative 3. When you set x plus 3 equal to 0, you get x equals negative 3. So you actually have two vertical asymptotes. One of them is 7 over 2, and the other one is negative 3. Now to find the equation of the horizontal asymptote, you're going to look at the degree of the numerator. The degree of the numerator is 2. The degree of the denominator is 2. The degrees are the same. So the way you find the equation of the horizontal asymptote is by looking at the coefficient. The leading coefficient in the numerator is 1. The leading coefficient in the denominator is 2. That's the equation of your horizontal asymptote. Y is equal to 1 over 2. And again, you can go back to, let's see, balanced. Okay, a balanced rational function on the top here, the degree of the numerator equals the degree of the denominator. So the horizontal asymptote is y equals a over b, where a is a leading coefficient of the numerator and b is a leading coefficient of the denominator. So let me get back to that page. The leading coefficient of the numerator is 1. The leading coefficient of the denominator is equal to 2. So y equals 1/2 is the equation of your horizontal asymptote. Now, if there's a horizontal asymptote, that means there is going to be no oblique asymptote. Oblique asymptotes only happen when the degree of the numerator is exactly 1 more than the degree of the denominator. You can check this by looking at the graph of the original function. You want to put the entire numerator in parentheses, divided by the entire denominator, plug that in, and then I do a standard zoom. This should show us two vertical breaks in the graph and a horizontal asymptote. So you can see right here at negative 3, you have this vertical jump in the graph. And over here at 7 over 2, which is 3.5, you have this other vertical break in the graph. You also see that the graph flattens out on the left and right side, and where it flattens out is close to 1/2.